Okay, now we're going to talk about subtracting integers. The interesting thing about subtracting integers is that you're actually changing it into an addition problem and then going back to the addition rules that we just covered. So, the thing to remember, it's like a chant. You have to remember, add the opposite. Here we have a subtraction problem with integers and they do have different signs. But before we can even start this problem, we have to change the problem into an addition problem, believe it or not. What you do is you leave the first number alone. Leave it alone. You change your subtraction sign into an addition sign. And then what you do is you add the opposite. The original number here was positive 4. The exact opposite of that number would be negative 4. So we actually change this number into its opposite. So instead of positive 4, we now have negative 4. What you do then is you fall back on your addition rules. And we know that when the two addends have the same sign, our answer will also have that sign. And then we simply add the absolute values. 3 plus 4, which gives us 7. And so our answer keeps the sign of our two addends, negative. We add the absolute values, 3 plus 4, which is 7. So our answer is negative 7. Let me do another example. For starters, let's start with a positive number this time. Positive 6, subtract negative 4. Again, before you can do anything, you have to change this into an addition problem. So the first number we leave alone. Leave it alone. Another thing you can do is rewrite the problem underneath. So we leave this number alone. Then we change our subtraction sign to an addition sign. And then what we do for the next addend is we have to take the opposite. The number here is negative 4. The exact opposite of negative 4 is positive 4. So we would change this into its opposite, positive 4. And again, this is our new problem. We have to fall back on our addition rules. The rules that we know is when the two addends have the same sign, that's the sign our answer is going to have. Then you add the absolute values, which would be 6 plus 4. 6 and 4 is 10, so our answer here is positive 10. Again, if the student needs to, you can draw pictures. You would draw 6 positive markers and 4 positive markers, and they can count up how many markers total, and what you would end up with would be 10 positive pictures. Again, another example. What happens if when we change it, then we have two addends with different signs? I'll show you. So let's say our problem is negative 6 minus negative 3. Okay, so we always have to do this step first in a subtraction problem. We have to change it into an addition problem and add the opposite. So again, the first number here stays the same, negative 6. We change this into an addition problem. And we take the opposite of our second number. The opposite of negative 3 is positive 3. Now we fall back on our addition rules. And what we see now is that we have two addends with different signs. We look at the addend that has the greater absolute value, the one that is furthest away from 0, which is negative 6. That is the sign our answer is going to have. So our answer will be negative. And then what you actually do is when they have two different signs, you actually subtract the two numbers, the absolute values. So the absolute value here would be 6. The absolute value here would be 3. 6 take away 3 is 3. It's a lot to remember. So as long as the student remembers to do this extra step and you end up with this problem that I have here in red, if it's too hard to remember all the rules, the student can always draw a picture. So as long as they remember this step and they get the problem set up correctly, then the student can draw their picture. So we would have 6 negatives. 1, 2, 3, 4, 5, 6. And we have 3 positives. 1, 2, 3. And what we learned is that one negative and one positive cross each other out and become 0. So these we can cross out. And you look at what you're left with. You're left with 3 negatives, and that's your answer. So our answer is negative 3.